Hi there, this is Yuchen, and I'm going to talk about my assignment 1 report. So first, I'm going to talk about how I relate this computer simulation to scientific computing. Okay, so the term scientific computing refers to a process of the use of computers, network algorithms, and computer simulations to solve various problems in the scientific discipline. Okay, so it is often thought of as a third pillar of science. The computer simulation is just one important step in the scientific computing. Generally speaking, we start the scientific computing process by making a model, and then we run simulations with the model to find some qualitative and quantitative insights of these models. So for example, in some situations, the physical experiments are impossible or dangerous or expensive, like such as the weather forecast, crash test, or nuclear test. Those studies can be replaced by the computer simulations, and with the simulation results we get by running thousands or millions simulations, we can further improve our physical or theological models. Okay. And then, so what is computer simulations and what is computer games? For me, computer simulations represents an implementation of a model which involves the variables that describe within that models and use algorithms to describe how the model works without ambiguities. So a model in this case is just a description of a system that we study. And this system is just a collection of elements that will act together to achieve some goals. So when we define the model, we will use different variables to describe the elements of interest and behaviors in the models. The algorithm here is not referring to something like data structure or binary search, but it's a set of instructions for accomplishing a task. So in other words, it's just a process that a model is to simulate. So without clearly defining the model and its algorithms, the simulation cannot be an accurate reflection of the models, and its behavioral outcomes is not really useful. Okay, so the computer simulation can be roughly divided into two types: experimental and experiential. The experimental simulation seeks to answer some questions, while the experimental simulation attempts to provide an environment with which one or more users can interact. So on the other hand, computer games are a bit harder to define. So in my understanding, a computer game must have first the rule that's or constraints to define a limited context. Second, an end to define the objectives. And third, it has a score to measure the progress and success. In addition to that, a game may also include elements like control, feedback, challenge, like enjoyment or fantasies. Okay, and there's a lot of people still arguing about the difference between computer simulations and the computer games. So the biggest difference between them is they're arguing is the realities and fantasies. However, a truly realistic computer simulations doesn't exist, or computer simulations requires abstractions to make them implementable. So the problem with realities as a means of separating simulations from games is that simulations themselves are never accurate reflections of realities, but always reflect someone's model of realities. So that is, all simulations are biased. And in my mind, all computer games are simulations, but not vice versa. So both game and simulations are used to express implementation of a model, and both of them have constraints and use algorithms to express the models. And it is true that some games have aspects that classic simulation normally lacks, but that doesn't make them something other than simulations. So for example, most games have external controls, while classic simulations may not need it. However, like nowadays, more and more simulation engine being built to take advantage of those devices, and even we can use game engine to build simulations. And on the other hand, not all simulations are games. For example, we can build simulations for the weather forecast, where we build a model and make some assumptions. However, in this case, it's not a game, because we don't need human interactions, and we don't need the end states. Okay. And how would I determine which of the three categories to recommend? Let's think of scenarios. So suppose a peer come to you for advice on their final project. They told you the topic but were not sure about the approach and ask your advice on whether they should implement it as a pure simulation, a traditional video game, or as a serious game. Okay, first of all, I want to clarify the definition of the pure simulations, traditional video games, and a serious game. In my mind, a pure simulation means that it is not just a game where it doesn't have an end or a score. And traditional video game must have rules, an end and a score. And the purpose of traditional video game is just for entertainment, while a serious game should have a purpose of teaching and training and health or advertising or so on, in addition to the entertainment. So in order to decide which category this person should choose, several questions need to be answered. First, what is the purpose of his project? This answer may vary, but it is related to if it is related to the entertainment or enjoyment, then it should be fair to the traditional video game. And if the answer is something other than the entertainment, then it should be fair into other tools. The second question is that do you need to achieve some goals to keep track of the progress? As I mentioned before, an end state and a score are very important aspects of a game, whether it's a traditional game or a serious game. So if the project is designed to have goals or need to report the scores, then it should be fair into a game. Otherwise, it should be purely simulations. So in general, these two questions should be enough for this person to make a decision. However, we can still ask further questions like what question your project will answer what are steps to build this project. So with those informations, we can compare the definition of them and recommend a proper way that they should follow.